In the previous video, we saw the postulates of Bohr's model, correct? Now, using that postulates of the Bohr's model, three important parameters we'll try to consider and we'll try to calculate. The first one is the radius of the stationary orbit, right? Now, during the radius of this, to calculate the radius of the nth stationary orbit, what are the parameters we have to consider? This is a very, very important point. Fair enough? Now, we are going to make use of one is, of course, the centripetal force we'll have to take, okay? And then we also have to consider the Bohr's second postulate, the quantization part. And also we'll have to consider the electrostatic force of attraction. Okay, these are the three parameters or three concepts what we are going to apply to calculate the radius, the nth orbit of a stationary orbit you can call it. Understood? So let's begin the particular derivation. By Bohr's second condition, MVR is equal to NH by 2 pi. You all know the values, so it's fine. Now, since you have MVR is equal to NH by 2 pi, V is equal to NH divided by 2 pi into MR. Correct? You got the value of the velocity. Now, why we need this? Because now we are going to apply the centripetal force and the electrostatic force of attraction. Now, if an electron has to be in stationary orbit, then the centripetal force and the electrostatic force of attraction should be equal. Otherwise, you will have an unstable orbit. Correct? So, mv square by r is equal to k into ze square divided by r square. Okay. K ze square by r square. K 1 by 4 pi epsilon naught. Ze square. See, that ze square, we can split it as ze into e. That's basically the nucleus charge and the charge of the electron. Okay, and r being the radius, obvious. One r gets cancelled, correct? Now, what is V value? NH divided by 2 by MR. So, if you substitute and make R as the subject of formula, you will get R is equal to N square H square by 4 pi square MKZ square. Now, what you can do, take that Z and N. So, here, if you take N square and then Z in the denominator, if you take that outside, guys, the rest of the value is constant, right? Isn't it? So what do we get? R is proportional to n square and R is inversely proportional to Z. Okay. Now for different orbits, okay, first orbit, second orbit, third orbit, the radius is going to become 1 is to 4 is to 9. In the sense 1 is to 2 is to 3. This is the radius or the orbit. Sorry, not the radius. If that is the orbit, first orbit, second orbit, third orbit, then the radius will become 1 is to 4 is to 9. Make sense? This is basically for the orbit, the radius of the orbit of some nth orbit you can call it. Alright, this is the first part. The second part, using the Bohr's postulate, what we can calculate is the velocity of the electron in the nth orbit. Okay. Again, we start with the same Bohr's second postulate. MVR is equal to NH divided by 2 pi. R is equal to NH divided by 2 pi mv. Correct? Then what we do? Again, we take the centripetal force and the electrostatic force of attraction. mv square by r is equal to k ze square divided by r square. Correct? Then again, what you do? 1 r gets cancelled. R is equal to k into ze square divided by mv square. Correct? Now look at both the equations. One what we got from the Bohr's second postulate, another one what we got from the centripetal force. Both of them are equal. They basically are value. Correct? Guys, equate both of them. If you equate both of them, we can calculate for velocity. So you get k into ze square divided by mv square is equal to nh divided by 2 pi mv. So if you make V as the subject of formula, because if you can see 1 V gets cancelled, correct? If you make V as the subject of formula, you get V is equal to 2 pi K into ZE square divided by NH. Okay. Now again, take Z and N separately in the sense take it out so that you know how velocity is dependent on the orbit. Okay, and also the atomic number. Alright. So if you take that out, what you get is that V is inversely proportional to N. Correct? That means the closer the orbit you have, that is if N value is very small, 1 or 2, something like this. Suppose if your orbit is closer to the nucleus, smaller the value of N, more is the value of V. That's why the one, that is, suppose if N value is equal to 1, then you'll get the velocity as 2.2 into 10 to the power of 6 meter per second. Alright, this is about 1 divided by 137 times the speed of light. That means the electron which is closest to the nucleus is going to spin in the sense revolve the fastest. The farther away you go, slower the electron is going to revolve around the nucleus. Okay, the second parameter is done. First one was radius, next one was velocity. The third one is the energy, which is a very important parameter. Because when we talk about energy, we also have to consider what is the radiation. Because energy doesn't come out as heat or sound or something like this. It comes out as a radiation. Let's try to calculate. Now, what we understand is that whenever we talk about energy, there are two types of energies, correct? Potential and kinetic energy. So the total energy is the sum of potential energy and kinetic energy, correct? Now, whenever we talk about the potential energy is what? So potential energy is due to the position and kinetic energy is due to the motion. Let's try to calculate what is the kinetic energy first. Alright. So for kinetic energy, to calculate kinetic energy, again we go to the case of centrifugal force. So mv square by r is equal to k into ze square divided by r square. Correct? Cancel off the 1 r. Multiply both the sides by half. That means LHS is going to become half mv square, and on the RHS you are going to get half k ze square divided by r. Next, what is half mv square? Isn't that the kinetic energy? So kinetic energy is equal to kze square divided by r. This is the kinetic energy of the moving electron. Now let's try to calculate what is the potential energy. Okay. To calculate potential energy, what we do, we take the potential of the body multiplied by charge. Okay. Now, electrostatic potential, you guys have already learned the formula for it, isn't it? Now, let's apply the same logic here. You'll get K into ZE divided by R into minus E. The negative E is because of the charge of the electron. So, you will get minus K ZE square divided by R. This is going to be the potential energy. Correct? The total energy is going to be sum of potential and kinetic energies. See, when you add, look at both of them. Kinetic energy is basically half of potential energy, but potential has a negative sign. Correct? So when you add both of them, you will get the total energy as minus k ze square divided by r. Okay, this is going to be the total energy. Now we substitute the value of r. Okay, if you substitute the value of r, then this is the formula for energy. Now, if you look at it very carefully, we have segregated that z square and square part, correct? Both the values. Now, why we do that? Because whatever the answer you are going to get will be in terms of joules, correct? Energy is in terms of joule. But then, we generally, whenever we talk about energy of an electron, we write in terms of electron volt. So what we do, we divide by 1.6 into 10 power minus 19. Alright. Then if you do that, you are going to get a value as E is equal to minus 13.6 by N square electron volt. Okay, N square electron volt. Now, these are three important parameters what is required. Radius, okay, this is the formula. Velocity, this is the formula. energy, this is the formula. And keep in mind, radius is inversely proportional to this one, n square. Keep in mind, radius is proportional to n square. So if we have 1 is to 2 is to 3, it's 1 is to 4 is to 10. Okay? Velocity is inversely proportional to n. That means, closer you are to the nucleus, faster the electron is going to rotate or revolve. The third one is the energy. Energy is inversely proportional to h square. In the sense, the smaller that is, the closer the electron orbit is to the nucleus, it is going to have, since it's a negative sign, we take that it has more energy. Okay, so these are the three parameters, what is very important and what we can deduce from the Bohr's postulate, what we have learned in the last week.